This is Gail Kovac for Gresham Barlow School District. This is summer school, high school credit recovery, Algebra 1A, and learning target number 10. I can write linear equations given a table or points on a graph. So we'll start with the graph over here on the left because we've already talked a decent amount about slope and y-intercept. So the form of a line is y equals the slope times x plus your y-intercept. So the y-intercept is the starting point on the graph where y crosses the x-axis. So right here, y is crossing the x-axis. Here's your beginning point at 3, and that's positive 3. So your y-intercept, that constant at the back, is going to be 3. Now we need to find our slope. Let's find another point here somewhere on the line that obviously crosses at one of these unit points over here. And it looks like there's one. It looks like there's another one here. There's another one here. There's a few you have to choose from. You can really choose any of them. And for argument's sake, I'm going to choose this one down here. So remember, your slope is your directions for how to get from one point, and we're going to start at the 3, to the next point. And we're going to call this one for now my next point. So the top value of your ratio is how much you have to go up or down, and the bottom number is how much you have to go left or right. All right, so to go from this y-intercept of 3 down to this point, I need to go down 1, 2, 3, 4. So that's down 4. And to the right, 2, 1, 2, forward 2. Now that is perfectly acceptable, or you might have chosen a different point. Perhaps you chose this point right here. That would be down 2, forward 1. And this here can reduce to down 2, forward 1 if you divide top and bottom by 2. So really, you can do it any way you want. There's nothing incorrect about this. It just happens to not be in fully reduced form. And most of your teachers are going to want it in fully reduced form. So for now, we're going to go down 2 and forward 1. That's technically how you get to the next point. Although you could have also said down 6 over 3, there's another point there, down 8 over 4. All of that reduces down to the same slope of down 2 over 1. So that's from a graph. And now what if you don't have the graph? What if you just have some of the data points here? You don't have the picture. Well, it's essentially going to be the same thing. Y equals, your slope is the value, the coefficient of x, it's multiplied to x, and then you've got your constant here at the back, which is your y-intercept. So your y-intercept is your starting point, and remember that is any value here where x is going to be equal to 0. So what we're looking for here on the table is where x is equal to 0, and I see this point right here. That is going to be your y-intercept, so that's the value that goes at the back, -2. That's your y-intercept. Now to find your slope, how to get to the next point, what I'm looking for is the rate of change. So starting here at the 0, notice that your x goes forward 1, and in this case, your y goes up 3. To go from -2 up to 1, that's plus 3. You might see that evidence again from 1 to 4, that's plus 3. From -8 to 5, that's plus 3. From -5 to -2, that's plus 3. Plus 1, plus 1, plus 1 every time. So each time x increases by 1, how much does your slope increase by? Your y increase by? That's your slope. So that's up 3 and forward 1. So you can leave it just like this, up 3 over 1, or if you don't want to bother writing the fraction with the over the 1, you can just write this as y equals 3x minus 2. That's fine as well. Both of these are perfectly correct. I like to leave the slope like this because then I see where you got that from instead of it just in its final, more cleaned up form. Now, something to note is maybe on your table, they've left out the 0. Maybe this just goes -5, -4, -3, -2, -1, and they don't see the 0. What you'll have to do is just continue the table until you find what value would y be when x is 0 in order to find that y-intercept. So watch out for those. You need the x equals 0 to get your y-intercept, and you need this rate of change for each time x increases, or how to get to the next point here.